Hi everyone, today I'm going to talk about the story of voltage. So the top part over here will be things that you need to know and memorize. So I'll run through the definitions and the equations first. EMF is what we call the electromotive force, and it's the work done by a source in driving a unit charge around a complete circuit. PD stands for potential difference. Potential difference across a component is the work done to drive a unit charge through that particular component. Equation for calculating voltage is shown here. It's simply work done divided by charge. And if you do a bit of units analysis, the units of voltage will be written as V, which stands for volts. And another way of writing volts is joules per coulomb. Joules per coulomb. And the units for work done is joules, the units for charge is coulombs, and therefore this explains why another way to write volts can be joules per coulomb. So, having said all this, what exactly is the meaning of voltage? This is what happens. In a circuit, there must be a motivation for charges to flow. The motivation for charges to flow is the EMF of the circuit. So it's provided by the battery. The battery provides an EMF. Say, for example, a typical battery that you would have used would be a AA battery, which is 1.5 volts printed on the battery. If I put two of these AA batteries together in series, I'm going to get basically if I draw it like this, a potential difference which is called EMF of 3 volts. Alright, so what happens is this. Imagine there's this bag of charges. So I'm just going to draw a lot of protons inside, and I'll call this my bag of charges. Alright, so this bag of charges, now I know it contains protons, and protons are not supposed to move, but people in the past do not know that, and they call it conventional current. So let's just assume that it is the protons that are moving in a circuit. So we have this bag of charges, and say this bag of charges is worth 1 coulomb. Alright, so I have 1 coulomb worth of charges. What happens is the batteries would have provided this bag of charges 3 joules worth of energy. So at this point, the voltage here is 3 volts. Why so? Because at this point, the charges here, for every 1 coulomb worth of charges, it contains 3 joules of potential energy. The charges move along the circuit, and say at this point, the voltage here is still 3 volts. Why so? Because the bag of charges have not used up the potential energy yet. So it still contains 3 joules worth of potential energy. Now, when these charges goes past a component, what happens is this bag of charges will give away the potential energy to the component. This will make the component heat up, or this will make the component light up. So after crossing over the first component, say the charges has given away, this is randomly say 2 volts of energy. So meaning after crossing over, the charges gave away, out of 3 joules of energy, they gave away 2 joules of energy to the component. They are now left with a voltage of 1 volt. So if I can find this bag of charges at this point, I will see that they have a potential energy of only 1 joules per coulomb worth of charge. And same thing happens, the charges will move across the next component, and say over here, the potential difference is 1 volt. And this guy over here is potential difference. This one over here is also potential difference. This means that at this point, my voltage of that bag of charges will become 0 volts. Yes, so at the end of the journey, the charges, the belt of charges, will give away all the potential energy that they have gained from the battery, because this potential energy would have been given to the components. So that is the meaning of voltage. I see voltage as a form of potential energy contained in a bag full of charges, which is worth 1 coulomb. And as the charges gain energy from the battery, it also gives away this energy to components. So if I utilize a very simple conservation of energy on this belt of charges, you will see that the energy gain by the charges must be all given away to the components. Alright, so the EMF provided by the battery the potential energy must be distributed across the components. So let's call this PD1 and PD2. Alright, so this is a simple way of connecting the EMF of the battery and show how the EMF of the battery relates to the potential difference across components in a series circuit. And that's it for our story on voltage.